Hello students, today we're going to be taking a look at section 14.4 entitled Secant Tangent Angles. You can find the measures of angles formed by secants and tangents by using the following theorems. First, if a secant tangent angle has its vertex outside a circle, then its degree measure is 1/2 the difference of the degree measures of the intercepted arcs. Second, if a secant tangent angle has its vertex on a circle, then its degree measure is 1/2 the degree measure of the intercepted arc. Third, the degree measure of a tangent angle is 1/2 the difference of the degree measures of the intercepted arcs. So I'm going to highlight the three specific relationships where you have a secant tangent, tangent tangent, outside the circle, where the vertex will be for the first. We're again looking at 1/2 the difference of the degree measures of the intercepted arcs. The second, vertex on the circle, just simply 1/2 the degree measure of the intercepted arc. And then third, tangent again, 1/2 of the difference of the degree measures of the intercepted arcs. So arcs do play a role in every single instance. The second is a single arc, while the first and third are multiple arcs. Let's take a look and apply these. Find the measure of each angle. Assume segments that appear to be tangent are tangent. Okay, so in this very first depiction, we're looking at very specifically a secant and a tangent. And the vertex of the angle just so happens to be on the circle. Okay, so this is a secant-tangent relationship again, but on the circle, noting that the second bullet, not the first, is what we're going to apply in context. Again, we want 1/2 the degree measure of the intercepted arc. So this is the angle in question. So angle 1 should be equal to 1/2 the intercepted arc. And we've got to be careful here. 80 degrees is not the intercepted arc. The arc that results here is. And if you think again about how the full degree value of a full circle can be applied in context, we are going to take 360 degrees minus 80 degrees, which of course is 280 degrees is the intercepted arc that we're going to be applying the math to, which is what, 1/2 of simply 280. So the measure of angle 1 simply ends up being half of 280, like I said, so 140 degrees. Okay, so number 2. It appears here that we've got yet another situation of which we've got a tangent and a secant. But in this instance, our vertex just so happens to be outside the circle. So this is technically bullet 1 or theorem 1 from up above. And again, because this is the case, again, the angle will be half the difference between the intercepted arcs. So for our purposes, I'll rewrite this down below. So the measure of angle 2 will be equal to 1/2 the difference of 200 degrees and 60 degrees, those two respective arcs. So 200 minus 60, of course, that's 140. Take half of 140, simply we end up with 70 degrees. Number 3, the measure of angle 3. So in this particular case, we are looking at a tangent and a secant, of which, again, if we note, like number 2, our vertex is outside the circle, so we'll use the same theorem. So our math ends up looking like the following. So the measure of angle 3 is equal to 1/2 difference of 155 and 51 degrees. In other words, we'll have a half of, let's see, that'll be 104, which then ends up, if we simply divide by 2, should end up being simply 4 divided by 2, of course, 52 degrees. So that is the measure of angle 3. Number 4, the measure of angle 4. This happens to be a tangent-tangent problem, so both of these are tangents. And it turns out there's only one theorem that speaks to this. The angle in question, angle 4 in particular, should be equal to 1/2 the difference. So 1/2 difference between the two arcs of 240 and 120. So if we do the math, we'll see here that if we subtract, we get half of 120 and 16. Now let's do another tangent-tangent problem. And then I will continue on here, possibly leaving some for you guys to try on your own, and or possibly doing some via audio lesson, because that's another way that we can kind of utilize our time correctly and appropriately. So again, this is a tangent-tangent problem in which, again, because we're talking about an angle that's outside the circle, it will always be that way. It is equal to 1/2 the difference between the two arcs. Now you don't know the arc that remains here, but I'm going to highlight that as such. I can find that arc simply by taking 360 minus 145. That, of course, should end up being an arc value of 215 degrees. So that's going to be the math that we utilize in this particular difference setup. So 215 minus 145. And that's 215 minus 145. And then, of course, divide that by 2. So 35 degrees is the measure. So as far as continuing on, let's maybe pick 2 more questions, of which are a little bit more interesting. I happen to think numbers 8 and 9 are more interesting. So let's take a look. So example or problem 8, we have what appears to be an angle that is created, the 47-degree angle in particular, created by a secant and a tangent. Okay. Now, as far as what the resulting arc value will be, well, let's reflect a little bit when we had done number 1 from the get-go, but also technically when we had done number 2. The angle is equal to half, when it's on the circle, of course, half of the arc that it's intercepting. So back to number 1, just to kind of speak about that briefly. Angle 1 was equal to 1/2 of 280 degrees. So in this particular case, we have 47 already as provided. We don't know the arc, which I'm going to label right here as x. Okay, so half of x is equal to 47. So if we multiply simply 47 times 2, that then leads to what? 94 degrees. So x is 94 degrees. Now remember, that's just the arc value. We're going to kind of work our way back to a prior section here, noting that the angle marked as 8 is going to be an inscribed angle. You could also attribute this to a secant-secant scenario, as we learned in another section, prior section to this. not necessarily assigning it as an inscribed angle, and really the same result applies. And here's what you would do. So the measure of angle A will always be equal to half of the intercepted arc. In this particular case, we already said that that arc is 94 degrees. So that will be the resulting math that I perform, simply dividing 94 by 2, and I'll end up with 47. Kind of a neat result of a situation in which we started with actually an angle that was 47 degrees, thanks in part to the theorem that we talked about earlier, the secant tangent theorem, when the vertex of the angle is on the circle. But again, kind of working our way back to another theorem that we learned in a prior section as well to finish. Number 9, good finishing question here. So the measure of angle 9 is what we're being asked to find. This is a tangent-tangent situation, so both of these are tangents. Now angle 9 is an angle that, again, because thanks to the formula where angle 9 is equal to half the difference between the arcs, I'm going to leave myself a little bit of an opening here for this subtraction of arcs. We can go ahead and do the following. So we happen to have a 45-degree angle that's inscribed. But kind of working back to, again, a prior section, 45 degrees is half of this arc right here. So if you multiply 45 by 2, you end up with 90. Okay, so as far as the subtraction goes, 90 will be the second angle, the formula of which, again, we've already set ourselves up where we're subtracting. We don't yet, however, have the larger of the two arcs. If we do that particular math, that should simply result in taking, 360 minus 90. And that particular result, I'll do it quickly here, should end up being simply 270. So if we do that particular math with 270 minus 90, dividing that by 2, clean that up just a bit. Here we go. 270 minus 90 divided by 2. And that ends up being, 90 degrees. So that's the resulting angle outside the circle. Again, this tangent-tangent relationship.